So, we will start with what is called structure from motion. This is just a continuation of what we have done till now, just that it actually escalates it even higher. This is called structure from motion. It's a kind of an intriguing topic, and it's nice in several ways. It's called SFM in short, and the structure refers to the 3D scene which you are imaging, and motion refers to the camera motion. So, the point is that until now what we saw was something like a stereo, where we said that if you had a stereo pair, then if you kind of knew the baseline, they can solve for the absolute depth. Now kind of what we are asking is, what if you have to actually take a camera and sort of go around, like for example, you may have, let's say, a fort or something, which you want to watch, which you want to sort of image, and then you want to build a 3D structure of this fort. Now you could take a camera, go around, and take images. So for example, this is like a camera, in, let's say, the pose 1, then this is like in pose 2, pose 3, pose 4, whatever, pose n, n camera poses you have, and normally it's the same camera. So you just kind of say take it around. It is not limited, by the way, You could also think about doing this for the case when, let's say, different people, it's a very famous monument and you've got different images taken by different people, and you want to still integrate them all together, That's even more difficult, but let's just get a look at the situation where you take a camera, you go around, Which is the simplest thing that you probably do, You have to go around an object of interest. It could be indoor, it could be outdoor, whatever it is, and you capture n views, as it is called, because there are n poses of the camera. So you have like n views of the scene, and in this case, it could also happen that you do not know exactly where you are, because you're just taking the camera and going around, You're not measuring that I did so much rotation, I did so much translation physically and all. You have no idea. You just go around. Unlike the stereo case, where we said that it's exactly like somebody gives you a very sort of a constructed situation where the two cameras are exactly apart, and then everything is perfect, and then the Z you can estimate, that you can find in terms of absolute values. But now, now as you can see, it automatically means that there is going to be some ambiguity now, because you do not know the exact motion of the camera. That becomes an unknown now. The camera could also involve, say, rotations and translations both, because there is no guarantee that you are going to be able to maintain it rotation free. So with respect to the first camera, you could have a pose, a pose change in second, pose change in third, and so on, So you have lots of pose changes, and the idea is that in such a case, what do you do then? And the simplest of this is actually what is called two view stereo, or two view is SFM, where see, typically when we say multi-view geometry, what we mean is the number of views is actually more than 3, greater than or equal to 3. There are at least 3 views or more. That is when this is called as a multi-view geometry. And there's a lot of stuff in this. So I'm going to just focus on things that are really relevant to us, but this is a huge subject in itself, multi-view geometry. The idea is that you can, so in two view, you've got like n equal to 2, and by two view SFM, what I mean is, again, the pose is not known, let's say, you do not know what is this relation between the two cameras, and you want to be able to sort of estimate. So the structure from motion, involves solving for this 3D scene as well as the camera motion, both are not known. It's like a joint problem now, and the way it is normally done is that you sort of get an estimate of the pose of the camera first, and then once the poses are known, then you sort of do a dense reconstruction, So normally, so I think let me just write down, and there are several advantages. You can also ask, what happens if there are n views? There are other advantages to having n number of views. There are advantages too, and some of them I'm going to list here. So it can give you better robustness to noise. So instead of just having 2 views or something, if you have, so instead of just 2 views, if you had multiple views, right. Then better say robustness to noise is one thing. Then you can have you can even perhaps use the additional views. The additional views can be used for, let us say, a verification purpose. Like for example, right, you might say that, right, from this view, from these two views, I am able to say something about a 3D point. Now, I might just want to use the additional view to just verify whether it is correct. Additional views can be used for the way for, let us say, verification perhaps. So, it is not always true, but then yes, you could use it. Okay, it is not like always you need to do that. Then this allows you a full 3D reconstruction. Full 3D reconstruction. What that means is, right, you see, from this camera viewpoint you will have a certain depth map, right. Like I keep telling, there is something called a depth map, right, which is like a 2D thing, on which you will see that each image point, if you kind of back project, where does it hit, right, and that kind of gives you the Z component. That is the depth with respect to camera 1, but then you have a depth with respect to camera 2, which is not identical to what you see from camera 1. Then you have a depth with respect to camera 3, which is kind of again placed somewhere else, because as you are moving, then your camera 4 and so on, right. So you have multiple depth maps, and you can actually think of a full 3D reconstruction. This is what they call as a 3D point cloud. I don't know, right? Have you played around with this kind of ply files and all, where you can actually rotate an object and try to see it from the sides and this and that? I don't know if you have done that, but right, that requires multiple views. With just one view, right, you cannot see what is on that side, right. If you just have one view, for example, right, this object, I mean, right, if it is curved and if I am seeing it from here, then maybe, right, depending upon the field of right, depending upon the field of view of the camera, right, you can only see so much, right. So here is the object, and okay, so right, so here is the object, and if it has a certain, the camera has a certain field of it, then you can only see so much, right. Whereas right, you might want to see what is out here and what is out here, and if there is a decent overlap as you go across these cameras, right, then you have more information of the same scene point viewed from multiple cameras, and the idea is that can you sort of integrate all of that in order to be able to arrive at something that gives you a more reasonable reconstruction, and also what we call as full 3D reconstruction by fusing depth maps. I'll just indicate later what do you mean by fusing depth maps. Okay, our idea is not to go into the details of that, but yeah, then you can think of fusing multiple depth maps in order to get what is called a 3D point cloud. And once you have a 3D point cloud, then just like the other day we talked about view synthesis, you can talk about depth from, let's say, wherever you want, right. So if you just do a projection onto that view of the camera, then you can get actually a depth map with respect to that view. Then you can go somewhere else, right, ask for a depth map from that view, you can get that. So in a sense, right, depth map is kind of is basically a function of the viewpoint from where are you seeing, right. So depth map is like view dependent, and you can actually fuse multiple depth maps in order to get something like a full 3D reconstruction. Then better occlusion and better occlusion handling, occlusion and visibility handling, right. What this means is that if something is not kind of visible from some viewpoint, perhaps that point reveals itself when you go to another viewpoint, right, and therefore you know that such a point exists. So from one view, right, you may not be able to see because something in the front is blocking it, whereas when you go and see it from here, then you know that, oh, right, there is a point there, right. So better occlusion and visibility handling. So all these are there. But then the key challenge is this sort of an unstructured nature, right, in the sense that you are sort of free to go around with a camera, and this is what you probably may want to do most of the time, right. You don't want to carry a rig with you and try to find out how much I am moving and all that, right. You will just want to take a camera, you take your cell phone, you go around. All right, so we'll start with actually 2-view SFM, because 2-view SFM is right, is good to kind of start with something simple, and then we will see, right, when you have multiple views, then how can you do something like a batch processing, right, because the idea should be to sort of combine all of them together so that one supports the other. But we'll start with what is called 2-view SFM.